Hi everyone, Timothy Ferris here with a few words about the multiverse. That's the idea that the universe we live in is not the only one, that in fact there may be many universes. Why would scientists take such a conception seriously? Well, it's not for lack of elbow room. The universe we live in is 13.8 billion years old approximately, famously contains zillions of stars and planets. As I've mentioned in other lectures, the universe we see around us is phenomenologically infinite. That is, we or any other observers can study the universe indefinitely into the future and never run out of things to learn. It's so vast and complex. And yet scientists do take seriously the idea of multiple universes, of a multiverse set of universes. Why? In this talk, I'm going to concentrate on three reasons that researchers are doing this. First, is what are called anthropic considerations, having to do with the fact that our universe is clearly capable of supporting life and intelligent life, by which we mean not to pat ourselves on the back, but simply that we're capable of doing science and investigating the universe and adducing things about its history. The second consideration comes up in the inflationary versions of cosmology, which are the most successful accounts of the history of our universe. And third, string theory, which has to do with the very smallest structures in nature. Let's start with the anthropic approach. This looks at the universe and notes that the constants of nature are not, as some scientists might have imagined they would be a couple of centuries ago when science was trying to get at the roots of things, that these constants of nature are not inevitable, but seem instead to be kind of arbitrary. The example I'll choose to focus on is the strength of gravity. This is the force that made it possible for matter to be drawn together and form galaxies and stars in the early universe. Without gravity at around its current strength, we wouldn't be here. Were the force of gravity much weaker, the universe would have simply expanded like a gas forever and would never have contained any sophisticated structures, and hence, we think, no observers. Were the force of gravity much stronger, the expansion might well have halted and the universe recollapsed on some short period of time, too short perhaps for thinking creatures ever to have evolved anywhere in the universe. So if you look at the existing strength of the gravitational constant, there are sort of two ways you could respond. You could say, as a religious believer might, and some have, well, this is how God did it. God fixed the universe so that we could be here. The trouble with those explanations is that they can be used to explain anything and therefore nothing. Or, as some theorists began to investigate decades ago, you can say maybe this isn't the only universe. Maybe the constants are different in every universe. Some of them can support life and others can't. But how could this be? How could there be many universes? An answer to that comes from our second point, inflationary cosmology. The inflationary theory was invented to deal with certain shortcomings in the naive early version of Big Bang theory, in which the universe had simply emerged from a point and expanded as we know it has. The trouble with that version of the theory was that there was not enough time provided for the various parts of the universe to ever have been in causal connection. So the uniformity of laws, the fact that hydrogen atoms behave just the same way over in that part of the universe as they do in that part of the universe, was inexplicable under the original theory. Inflation solved that by portraying the beginning of the universe as a rapidly expanding bubble of space. Started smaller than an atom and expanded very fast, much faster than the speed of light. And it can do that because it's empty. And once the universe got to around the size of a soccer ball or so, this very rapid expansion rate slowed down abruptly, and all the energy that had been tied up in that empty bubble precipitated out as the quantum fields of matter and energy that we've seen around us ever since. The inflationary version is now widely accepted in cosmology. It's the best theory of the early universe that we have, but it contains an interesting implication, which is that inflation shouldn't have happened just once. Any kind of space that can nucleate off a new universe, as some pre-existing space might have done in the inflationary model, will keep doing it. The conditions have to be correct, and you'll only find them in certain parts of the universe, but the newly created universe will go on creating other universes. And the implication is pretty obvious that if our universe began as a bubble that nucleated off of a pre-existing space, then that space too must have created other universes, other bubbles. Each of these universes would have had a different set of constants of nature, a different set perhaps of scientific laws. An interesting philosophical question to ask is which constants of nature or mathematics that apply in our universe would also apply in other universes. Fundamental arithmetic, 1 + 1 = 2. Hard to imagine that would be different anywhere else. What about the quantum of action, the basis of quantum physics? Seems like that would be universal, but some of these other constants, such as the strength of gravitation, would not necessarily be the same at all. There's no reason to imagine they would be. So if inflation is taking place, and many, many universes have been created by branching off from existing universes, then we would see a vast array of different laws. Some of these universes would be capable of supporting life and others would not. That's the anthropic consideration. Now, those who prefer to believe in a singular genesis might be troubled by the inflationary picture, but the history of cosmology is full of disappointments to preconceived ideas. Some folks were disappointed to discover, for instance, that the Earth is not the only planet in the universe, it's not at the center of the universe. So finding that our universe is not the only one would just be the latest in a chain of these disappointments, which nature turns out to be richer than we thought, and our role in it to be rather smaller than we had assumed. Andre Linde, the physicist who did a lot of work on this branch of inflationary theory, likes to compare the many universes in the theory to apples on an apple tree. And he did a calculation. If you find yourself in one apple, our universe, and you try to trace your history back through the nucleation of your universe off a pre-existing space and perhaps its nucleation off of another pre-existing space, although pre-existing, arrows of time are not really in the ballgame on this level. How far would you be from the original Genesis in which it all started, if there was such a thing? And the answer he got was that it's infinitely far away in space and time. Every observer would find that his or her universe, or its universe, was infinitely distant from the original Genesis event, if there was ever such a thing in the first place, or even if the term first place has any meaning in such a theater. So anthropic considerations raised the prospect of many universes. Inflationary cosmology suggests that the mechanism that produced our universe would function widely and would have created many other universes. In fact, it even suggests that you could make a universe in a laboratory if you had a sufficiently highly developed technology. If it worked, you wouldn't be able to see the new universe because the umbilical connecting the two spaces would quickly close off. You'd have a little poof of X-rays. That would be, if you read them right, I suppose, your confirmation that you'd made another universe. If anyone ever came into existence in one of the universes you had made, they might well worship its creator, who would be you, the lab technician. But they would be deists. The correct position would be that, somebody created it, but the creator is not interfering with the way our universe goes forward in time. The third reason for envisioning a multiverse is string theory. As you may know, string theory has been going on for decades now. It's often talked about in terms of its frustrations in trying to find a fundamental groundwork for nature. But it's done some things that are very interesting, and Leonard Susskind at Stanford University points out that string theory turned out in its 5 different versions to be describing what you might call the edges of a space that contains an enormous number of potential kinds of vacuums, potential spaces, architectures of space out of which universes might be made. So string theory seems to be pointing to multiple geometries of space, as you would have in multiple universes, as one of the fundamental ways of looking at nature. And Susskind notes that some of the spaces, thousands of them, but a small subset of all potential spaces, resemble the universe we live in insofar as they have expansion rates comparable to the expansion rate of our own universe. And we know that works for creating life. It's certainly not the only parameter that could permit life, but it's one that we're familiar with. And what string theory seems to be telling us is that from the vast number of different forms of space available to nature, there are quite a few, a minority, but quite a few, that, like our universe, would engender sooner or later that living creatures and observers might appear. The number of such classes of space that would resemble our universe is huge. It's 10 to the 120th power, according to Susskind's research. So even if there are zillions of universes, the subset of them that would permit life could be very large. All that said, how many universes might there be altogether? You have all these different kinds of space and all different kinds of other parameters. Is there some total number that a theorist can guess at? The largest one I'm familiar with is infinite, and it comes out of a work by Max Tegmark at MIT. He suggests that every mathematical conception, the few sets of mathematics that apply to our universe and the many others that don't seem to have any application to nature here in our universe, are all real. That the universe somewhere or other, some universe or other, expresses every mathematically possible form of existence. Well, that's pretty lavish, and I don't know, obviously, whether it's true or not. But it does respond to one interesting fact that we can observe about nature here at home. If I look out the window, I see walnuts on the ground under walnut trees. Not one walnut, lots of walnuts. Nature doesn't tend to make just one of anything. It doesn't make one galaxy, one star, one planet, one living creature, and it probably doesn't make just one intelligent species either. So perhaps nature's predilection for extravagance is written out in the existence of many universes as well. Hey, thanks for listening. See you next time.